Hey there, welcome to Azure Made Easy. In this webinar, we're going to take a look at Azure from the beginner's perspective, and we're also going to unveil a lab environment we've been working on here at StormWind to help you get up and running quickly. So I know that we got a bunch of people logged into the chat. I'll be keeping an eye on the chat as we go forward. And what we're looking at today here is, if you're getting started with Azure from the beginning, it can feel really overwhelming because there's so many services. And one of the things I like to focus on when somebody's new to Azure is the core services: compute, storage, networking, and security. So we're going to focus on that a lot today. And we're also going to focus on a little bit about the Azure Range. So the Azure Range is it's a hands-on lab environment. So imagine if you were going to go golfing, if you wanted to master golfing, you probably wouldn't go and do 18 holes right away. You would go to the driving range and practice your swing, right? So that's kind of the idea. The Azure Range is a way for us to spin up sandboxes and kind of test out some of the best of what Azure has to offer. So in this session, I'll be covering those core services, and I'll be taking you through a lot of beginner-related content. Like I said, it can be really overwhelming when you're getting started. But if you're getting into something like the AZ900 certification, which is Azure Fundamentals, the content here in this webinar, I think will really help with that. But regardless of whether you're interested in the certification or not, this is a good kind of jumping ground or jump start to getting started. So I see a lot of people connected in. I see Bob from Kansas City, Mike from Iowa, Becca from upstate New York, Israel from California, Dan, South Dakota. So welcome everybody. Excited to have you here. So the other thing I'm going to talk about today too is kind of addressing common pitfalls and anti-patterns. So like, even though we're going to learn cool stuff about Azure Compute, storage, networking, security, like what are some of the things to watch out for? What are some of the things that normally get us stuck? And then also going to just give you some practical ideas on how do you take what you've learned from this session and go and put it into practice. And I think you'll find that Azure is a really easy way to build some really compelling solutions. And I think you might be surprised by the time we get to the end at how easy it can be to get things up and running. So let's dive in. What we're going to do first is we're going to cover storage. So obviously data underpins everything that we do. And we're going to cover the Azure Storage Service first. The other thing about these core services to keep in mind is that everything built on Azure is built on top of these core services. So we can't have an Azure Kubernetes service, for example, without compute, storage, networking, and security, right? So everything on the system, on the platform, is built on these core services. So we'll start with storage first. And I'm going to show you the storage sandbox in the Azure Range. The storage sandbox is basically giving you a storage account and then a virtual machine to work with that storage account. Okay, so ultimately, technically, we don't need to have a virtual machine here, but it is kind of interesting to be able to like map drives to file shares in a storage account. Storage accounts are kind of multi-purpose, so I'll get into that. What I want to do first, though, is I want to show you how we would spin this sandbox up in the Azure Range. So this is me signed into the Azure Range right now, and you'll notice that on the top, we've got all activities. Right now, we've just got a set of sandboxes that kind of map to these core services. We're working on a project right now where we're building a bunch of step-by-step hands-on labs, but these sandboxes are just environments that you can spin up quickly, have some infrastructure in these core services to work with. And then I think the stuff that we cover today will give you a lot of ideas. In the future, if you hit the drop down here, you'll see that we have guided labs coming soon. I've actually been shooting an exam crash course recently for the AZ900 certification. I'd be interested to hear if anybody in the chat who's watching right now is interested in that certification, because I'm going to be building labs for that, and then further on from there to more advanced certifications. But if I want to spin up a storage sandbox, I know a lot of you are already StormWind subscribers. When I come into this Azure Storage Sandbox, I have the ability to pick the region where I'm going to launch this. You can see right here. And then ultimately, it's as simple as clicking on Start Sandbox. We've got our diagram of the environment. We've got a list of what's included. If I wanted to get into that virtual machine, I've got the credentials here. We give you some ideas to work with. But let's go ahead and spin this up. I'll talk about the storage service a little bit, and then we'll take a look at some demos. Okay. All right, so that's what we're going to do. This is the environment that we're going to have once that sandbox is up and running. And by the way, just to show this real quick, check this out. The lab is now provisioned, so I can literally go into the Azure portal by clicking on that link. That'll take me right into the sandbox. There is that infrastructure that's being deployed right now. So we're spinning up the virtual machine, we're spinning up the sandbox environment, we're spinning up that storage account. So it'll take about 2 minutes. I could click that link and go now into the portal if I wanted to, but I'll wait on that. All right, so let's get into the storage service, talk about what it is and how it works. So basically, like I said, multiple services are included kind of in this storage account. So we're not just talking about file shares that we might access using the SMB protocol, or like we might do a mapped network drive. We could do that, but there's also the concept of blobs, which we'll talk about, and traditional files, and then queue and table storage as well. So it's like a multi-purpose solution. So for system admins that want to offload file shares on-prem, put it in the cloud, we can do that. If we want to do things for development, unstructured data, we can do that as well. That's kind of the big idea. So when it comes to unstructured data, we're talking about images, backup files, videos. Structured data would be tabular data. So something you would see like in a spreadsheet with columns and rows, or something you would see in a database table. So we can do that from a developer perspective. We can use these storage accounts for structured data, which is really interesting. Queues are really a kind of a buffer between applications. So that's very developer centric. I don't want to get into that, but a lot of companies will store static assets for web applications in Azure storage, images, CSS files, videos, that kind of stuff. Blob stands for binary large object. So again, unstructured data. Give you an idea, I had a customer several years ago that did mapping software, and they would take aerial photos of very high resolution, and the images would be several gigabytes in size, and they'd had thousands of these images. So we would refer to those as blobs as we upload those into the storage account. The storage account itself also has tiering, so cool, hot, cool, and archive. So the idea is that I might upload a blob, a file, an unstructured type file, an image, a video into Azure storage. By default, that goes into a hot tier, meaning frequently accessed, but there are other tiers where we pay less money for the objects that are stored in the storage account if we're not going to access them as frequently. We can also set up the storage account so it's backed by solid state disks rather than a magnetic based storage, right? So for all of you hardware interested people out there, we know that magnetic disks with the spinning platter tend to fail more often. Solid state disks don't have any moving parts. The throughput, the latency is much less. And so that's also something we could do with Azure storage. But with these tiers, we can take things from hot storage, frequently accessed, go to cool, and then ultimately go to archive, where maybe we're storing stuff for 7 years or something like that. And it's insanely cheap once you start getting into those cool archive tiers. So very compelling use case if you're trying to offload data from on-prem and host it in the cloud. Common use case also from a sysadmin perspective, storing backups, log files, and things like that in there. And ultimately, you're going to create containers in the storage account to store the files. So let's jump over to the portal here. I'm logged in. Sandbox is up and running. You can see the warning about the infrastructure loading is already done. So we'll just jump into the portal. Normally, you'll be prompted here and challenged for multi-factor authentication. We have a whole process for that. I already did that today as I signed in earlier, so it's not prompting me for that. But notice down here, a little bit hard to see, right here is the storage account itself. Everything else is related to the virtual machine. The public IP address, the virtual network, the interface, the disk, all this other stuff is the VM. This is the actual storage account, and these are public by default. So meaning they have a public URL, and you can go to them in the portal to upload and download objects, or we can work with them in the command line interface as well. We can even build our own applications. But one of the things I wanted to show you real quick is if we come into the storage account, on the left side, we see data storage, and there's containers. That's where we would store blobs. There's file shares, where we would store SMB or NFS type file shares for Windows and Linux. And then these two down here, this is developer centric. So developers would use tables and queues to use Azure Storage as a cheaper alternative to something like a relational database like Azure SQL, for example, okay? And if I went into containers here, we're not talking about Docker containers either. So come into containers and say uploads maybe, and create a container. And then once we have a container, that's just a folder. We can upload blobs in that. And if I come in here and just do an upload, browse for a file, I'll just grab one of these zip archives from the list here and then click on upload. So it automatically goes into this hot tier. I could actually change that later. I can change that through lifecycle policies, so I can do it automatically. So I could say, hey, after 30 days, go from hot to cool. And then maybe after like 90 days, I can go from cool to archive, right? So that's something I could automate. It's also something I could do manually. All right, so going a little bit further here with storage, I know we're moving pretty fast, but stick with me and feel free to throw your questions into the chat. In terms of those file shares, these are real file shares that you would see like on a Windows or Linux server. So you just go into the file share section of what we were just looking at, and you can create shares in there, and they'll even give you a script that you can use to map those drives, whether you're on the Windows operating system or the Linux operating system. So SMB and NFS protocols are supported. And a lot of people will use this for lift and shift migration of file shared data into the cloud. And then you can map all the drives from all the VMs to that file share. There's a question in the chat that said, is this a paid feature? And it is, but it just comes, it's part of the storage account itself. So the way that the storage account works is you're paying for capacity of what you're using on disk, and then the throughput of the activity of reading and writing to that data. So it's kind of a sliding scale, depends on your usage. And that's really what cloud is all about, is paying for what you're using. It's like a utility service. So that's a great question. There's also a service that Microsoft has that integrates here that will replicate on-prem file share data to these file shares in the storage account, or vice versa, from the storage account to an on-prem machine. So really interesting, insanely interesting for that hybrid cloud kind of use case. All right, now storage redundancy comes into play when we're talking about making sure that we're not going to lose data, and eliminating single points of failure is what every cloud engineer is really responsible for doing. So we want to think about that. You may be aware, if you have a little bit of exposure to Azure, that the whole system is built on a regional kind of design. So for example, I'm in the West Coast of the United States. There's a couple of West Coast regions. There's regions all over the world, and we can strategically place our infrastructure in these regions. So you might have noticed when I launched the sandbox, it was in West US 2. And earlier in Azure's lifespan, regions were basically just a single data center. And so if I was using West Coast, it would just be one physical data center in the West Coast. But these days, regions are comprised of multiple data centers, and Microsoft was inspired by Amazon Web Services with this to create the concept of availability zones. So availability zones are distinct data centers within a region. So I launch a sandbox into West US 2. West US 2 has Zone 1, Zone 2, and Zone 3. Those are three physically distinct data centers in that West Coast region that are separated by at least 10 miles or more. That way, if there's some kind of natural disaster that wipes out an availability zone, we can still keep going. But the thing with that is, the reason this is important when it comes to storage is thinking about how to configure the replication and the durability for your data, because obviously data is critical for every business. We don't want to lose it. So we have a couple of different concepts here. Locally redundant storage has been around from the beginning. And what this does is it creates 3 copies of your data. And by the way, with Azure Storage, Microsoft's always creating 3 copies of your data, no matter what. So locally redundant storage is kind of like the bare minimum. That's going to be one data center where there's 3 copies of your data. So you upload a blob, Microsoft's going to make 3 copies of that blob in one data center. Geo-redundant, keyword here, geo, that's for geographic redundancy. So I might have West US 2 and East US as a secondary failover site for my data. So I would have 3 copies in my primary region and then 1 copy in the remote, like West Coast, East Coast scenario, okay? There's also a read access where it's kind of a read-only geo-redundant storage. And then zone redundant is a little bit of a newer concept since Microsoft introduced the concept of availability zones. If we're choosing ZRS, that's going to be more expensive than LRS, but it's going to make it zone redundant. So the 3 copies of the data will go into zone 1, zone 2, and zone 3, right? So pay a little bit more, but you'll have more durability, meaning, we see here 11 nines of durability is kind of like the minimum for Azure storage. And depending on the pricing tier that you pick and the way that you configure things, that can go even higher. But essentially, we're talking about the integrity of the data, the chance that you're going to lose any data with this much redundancy. The storage system is so advanced and huge, like we're never going to fill it up with whatever we can throw at it. Microsoft's got plenty of capacity there, and we're probably never going to lose any data because the data is so durable. Microsoft's making 3 copies, giving us the ability to do even more. So I think last time I checked, I'd have to double check the math on this, but I think 11 nines means like out of 100 billion blobs you might upload in a year, you might lose 1, okay? But data loss is not something that I've ever experienced in Azure from a storage perspective, unless it was my own mistake, right? So I wouldn't worry too much about that. And you could rest assured when you're using Azure storage that your data is redundant, okay? So massive set of capacity and performance, plenty of durability, storage encryption by default. So all of the read-write activity is encrypted through TLS, and then it's stored on disk in an encrypted format. Even if you're not supplying in your own encryption keys, Microsoft will do managed encryption for you by default. So you upload a blob, they'll encrypt it as it's written to disk. And if you read that back, it'll get decrypted on the fly. You can even choose to do your own customer managed encryption keys if you don't want anybody else, including Microsoft, to be able to decrypt your data, okay? And ultimately, we deal with this service through the portal. The web portal is built on the REST APIs. So we can build applications that use those REST APIs with SDKs. But, so if you're wanting to upload and download blobs from the storage account, you could use the portal. There's also a a locally installed storage explorer you can install. There's command line interfaces. So there's a lot of ways to work with it. There's even commercial tools that some of you may have worked with that integrate directly with Azure storage. Okay, so that is something to think about there. Now, one thing that a lot of people don't realize is that this storage platform is where virtual machine disks are stored. And this goes back all the way to the beginning of doing virtual machines on Azure. So when we're doing virtual machines in Azure, does anybody know the hypervisor that Microsoft uses by any chance? Well, probably not a big surprise that it's Hyper-V, right? So if you've done any work with Hyper-V and virtual machines there, you know that there's a VHD disk format for those virtual disks. Those go into Azure storage. So we can basically build these virtual machine disks and have it like automatically go into a storage account. I'll talk a little bit more about that. But ultimately, they can be backed by magnetic disks. So that's the HDD option, SSD or premium SSD, which is going to give you the much faster read-write performance. This is for operating system disks and secondary disks that you would have on your virtual machine. And then there's a concept of managed versus unmanaged disks. And really the big takeaway with this is that these days we want to use managed disks as a best practice. And this is the portal and the tooling will lead you down that path. So it's kind of hard to do classic. You have to know kind of what you're doing, but this could come up on like an AZ900 exam, but it's also just good to know. So originally, a couple years ago, when you built a VM, one of the dependencies for the VM was a storage account because you had to tell it, hey, put my VHD files for all my disks for this VM in this storage account. So you needed to have either an existing storage account or build one as you're building the virtual machine. Problem with that is it gets pretty hairy after just a couple servers, right? You got 10 servers, 20 servers. Now you're thinking about 20 blobs at least for the OS disk. And then what about secondary disks? And if you start storing the disk for every single virtual machine in one storage account, the storage account becomes a bottleneck because it's only got so much capacity at the storage account level. It's only got so much throughput capability at the storage account level. And so it just got to the point where doing that wasn't scalable or sustainable. So Microsoft came up with this concept known as managed disks. And that means that when you build a virtual machine, and you specify the disks that you want for that virtual machine, the VHD files will automatically go into a storage account that you don't even see. And Microsoft will make sure that based on the capacity that you've chosen for that disk and based on the IOPS that you've asked for on that disk. Anybody know what IOPS is? IOPS, input output operations per second. How much can I read and write to that disk? You tell Microsoft what you need on the disk level, and then they'll figure out on the back end how many storage accounts need to be created to work with all that. And so it's all completely automatic from that point. That's the much better way to go. And so if there's any question about that, you always want to use managed disks and know that even if you don't see a storage account in a resource group alongside your virtual machine, the disks are in Azure storage. And again, there's 3 copies of that data no matter what, right? So you've got that durability there. All right. Pitfalls with Azure storage, okay? Overpaying for redundancy. This is one thing I've seen a lot of customers do where they set up, sounds good, geo-replication. Wow, let's do that. Well, if you don't really need geo-replication, you could end up paying double when you don't need to, right? Because you've already got local copies, locally redundant, 3 copies of storage. So that's something to think about. This is a huge one, data egress, pulling data out of Azure. Especially if you're doing cross-region transfer or sending data back to on-prem, or just having end users download videos, from an application that's using the storage account. That's all egress. They're charging you for that. So you got to watch out for that. That could be one of those hidden costs in Azure where you're like, oh, okay, I know what the VM costs per hour. I know, this and that, but sometimes people forget about those egress charges. I actually saw a customer do this several years ago where they were building a video application and they put all kinds of videos up there in a storage account. Those were embedded into web form where people would watch the videos, but they didn't realize that outbound data transfer was going to be costing them, right? So you got to think about that. The Azure storage or the Azure calculator, there's an Azure calculator online. You just go and do a search for Azure pricing calculator. Every single service that exists will be there, and then you can figure out what the cost is and what the hidden costs might be that you might not be thinking about. All right, and then leaving data in the hot tier is another one. Again, those tiers, we can go from hot to cool to archive. And again, there's lifecycle policies that we can set up that do those moves for us. So, if you're uploading data that needs to be archived for 7 years, don't leave it in the hot tier. Go ahead and put it in maybe the archive tier. Okay, now one thing that I don't really have time to show on the storage, I was going to show mapping the disk from the Windows server over to the share that was in here. I'm going to go ahead and skip that for now, but I would say that if you are a StormWind subscriber, go ahead and request access to the Azure Range and try that out yourself. You could spin up the storage sandbox. You'll be able to RDP into that Windows server. And then you could just go over here into the storage account, go to File Shares. I created one in here. You'll see a share that exists by default when you launch the sandbox. And then if you go in there, they will give you a script to map it. You just got to go to Connect up here at the top. And then they will give you a script for Windows, Linux, Mac OS to do that drive mounting. Okay, awesome. Let's get into compute. All right, so before I get into, let's do this. Let me show you the compute sandbox. So compute is interesting because it's a lot of times you're just thinking, oh, virtual machines, but it's really more than that. It's managed application infrastructure like app service or application environments for running containers. So what I'm going to do here is I'm going to go ahead and spin up the compute sandbox. The compute sandbox is another one on the list here. So let's go back to library, go to compute, and we're going to spin this up. Again, it's going to launch a bunch of infrastructure in there, a virtual machine, the app service, which I'll explain, and also an ACI container group, which is a way to run Docker containers on Azure without building virtual machines. All right, but this is essentially the architecture here. So these resources are kind of just independent in that sandbox. So to give you an idea of working with the different compute services. So Azure's IaaS compute option is virtual machines. And you may or may not know this, but IaaS is pretty much the most admin intensive way of doing things in the cloud. It's really just kind of mimicking what you're doing with virtual machines on-prem. So there's a lot of work there. So that's just one thing to think about. If I'm building a SQL Server cluster on my own VMs, right, there's going to be a fair amount of work from a virtual machine perspective where I could just go to Azure SQL and get a database from Microsoft and not think about the infrastructure as much. So that's kind of the big payoff with cloud. But virtual machines are pretty well established, right? Like the big takeaway is you got to do all the management. You got to manage the OS. You got to patch it. You got to make sure that for the local user accounts, you're doing secure passwords and rotating those passwords. And you got to make sure that highly available if it's a production application, so that think load balancing, think deploying VMs at a different availability zone. So a lot of work to make something production ready in a traditional sense. But we can do Windows and Linux virtual machines. That's probably pretty straightforward and obvious. Now, App Service is a PaaS offering from Microsoft, and this is the place where we do web applications. This is probably one of my favorite services on Azure. And by the way, this is what the Azure Range runs on. It's really just a hosting environment. And this pattern has been in Microsoft's Azure platform really from the beginning. Azure started as a developer's platform for hosting web applications. And so the app service functionality has been around forever, and it works really well because it's been around for so long. But this thing will handle all of the considerations for doing a production grade web application. So if you need an app service plan backed by 2 or 4 virtual machines, and those need to be load balanced, of course, the app service plan and hosting environment will just take care of that for you. You just tell Microsoft, hey, this is the tier, the pricing tier that I want. And I want load balancing, and I want even auto scaling as an option. So ultimately, this service is backed by virtual machines and all the traditional IaaS infrastructure. It's just that you don't have to do any of it, and you can just focus on the application. It's really interesting because not only does it do all the heavy infrastructure stuff for you, but the CI/CD integration is insanely good. And it's really easy to set up. If you spun up that compute sandbox, you could go into the app service plan. And matter of fact, I'll just show you that right now. This compute sandbox is up and running. So let's jump into the portal. And so the app service plan is like a hosting plan. And then just like you would in a web application or a web server, you can put multiple web apps on top of the hosting environment. So down at the bottom here, you can see that I've got my web app. And then there's this app service plan, which is like the hosting environment. But if I go into the app itself, and then I go over the left-hand side, let's see how there's a deployment option here? In here, you can go to Deployment Center, and it's insanely easy to come in here and map this application to like a GitHub repository, Azure Repos, which is Microsoft's version control repository. But the thing that's cool about this is that if your app is already in GitHub, you can connect it here, and then this will enable continuous deployments to the Azure App Service. So anytime a developer checks in code to GitHub, boom, it gets deployed into Azure. And you can have that go into a development slot or the production slot. So kind of depends on a scenario, but for quick and fast iteration and development, It's insanely awesome. And that's pretty much the pattern that we use for the Azure Range. Our web application runs on app service. We do continuous deployments from GitHub, and it works great. And no virtual machines, no patching, no backups, none of that. It's awesome. I still love virtual machines, don't get me wrong. Now, containers, a lot of people are talking about containers. What I've found is that a lot of times it's still relatively confusing for people. I work with a lot of people that do web development or systems administration, stuff like that. Across the board, I've noticed that containers are still kind of a new thing for people, which is fine. But from a development standpoint, it's really cool because it makes life much easier for developers. So on Azure, there's a bunch of compute services that let us run containers. Azure Container Instances, that's kind of similar in concept to app service in a way. And ultimately, though, it's a PaaS service. So really, you just have to think about your container images and getting those up into Azure somehow. There's different ways of doing that. And then you could run your web applications through ACI, Azure Container Instances. That's good for smaller or medium-sized applications. Bigger implementations, especially like microservices for any company that's building like a real big platform. Maybe it's a mobile backend for a really heavy used mobile app, right? That's a good use case for microservices, and microservices run on Kubernetes. So for more advanced and kind of like hardcore containerization and orchestration is what that's all about. Kubernetes is about orchestrating containers, making sure that they're running in all these different services and they're redundant and all that. That's also an option as well. All right. Scale sets is another thing that's really cool on the compute side. Think auto scaling here. So instead of me having to right size every environment, I can have an auto scaling situation to where, hey, if we get a sudden surge of traffic and we're suddenly, hitting 90% CPU on the infrastructure, and that's persistent for 10 minutes or so, let's go from 2 servers to 4. And then when that demand dies down later, we go from 4 servers to 2, right? So it's horizontally flexible and scaling. So we can do that based on performance, and we could do that based on scheduling. So we might schedule that to happen. Hey, we want to go from 1 server to 3 Monday morning at 8 a.m. and go back to 1 server at 5 p.m., that kind of thing. So ultimately, these environments tend to be load balanced by default. So you're deploying a scale set, it sits behind a load balancer. That's kind of the big idea. So it's awesome for horizontal scaling. Now there's also vertical scaling that you'll see all over the place. And what that means is going from something smaller to something bigger. So scaling up. So an example would be if I'm on an app service plan and I want to go from an S1 plan to an S2 plan that provides more infrastructure, more firepower, I can scale that up. I'm going to pay a little bit more money. Same thing on a virtual machine. If I'm using a VM that has 1 vCPU and 1 gig of memory, I can scale up and I can go to something more capable with like 2 CPUs and 32 gigs of memory or something like that. So that's all stuff that you'll see over time. So ultimately, when it comes to choosing the right option, it's all about like the administrative overhead. So if you don't mind, like pretty much shouldering all the responsibility, IaaS is a way to go. If you want like the easiest and quickest way to go in terms of administration, PaaS services are really interesting because it does promise or deliver on the promise of cloud native capability and making life easier for you. Okay. And then finally, one thing I didn't get into today, I'll have to do this another time, but Azure Functions. You hear people talking about serverless, right? So Azure Functions are a FaaS solution, so functions as a service. Ultimately, it's a PaaS service. And instead of thinking about VMs or any of those abstractions, we're just thinking about blocks of code. So in an application, I'm going to have code that inserts, updates, deletes, and does various things to the items that I'm putting into the database, for example. I might have an independent function for each one of those and use it like as a part of a backend for an API. Or we can use functions to do event-driven automation. So think about this, like you upload an object into cloud storage, into Azure storage, and then you have an Azure function automatically run based on that event. So it's all automated, and maybe that function goes off and and does something interesting like tag that resource with metadata or something else. But these functions can be used in a really interesting way to respond to events. That's one of the things I'm excited about going forward with cloud, is to see how that kind of plays out and how people use it. Okay, so from a compute standpoint, what are some of the pitfalls? Well, running VMs 24/7 could typically, or could potentially be a problem. Sometimes you need that availability 24/7, but if you got like VMs that are hosting a computer lab environment, which I've seen people do that before, have dumb terminals connecting to VMs, shut those down at the end of business, automatically spin them back up in the morning. So we can schedule that to happen, and it's built into the Azure platform. So if you go into the properties of a virtual machine and scroll down on the left side and poke around in there, you'll find the ability to do that. Choosing the wrong size for your virtual machine is kind of a common pitfall, especially if you don't go back and look and see, like, did we over provision this? Are we not even using the CPU and memory as much as we thought? So it's a good idea to right size those workloads. There's something called the Azure Advisor that'll help you do this. Just get the right resource configuration so you're not overspending. Using VMs for everything would be considered mainly kind of a pitfall or anti-pattern, because again, we can save a lot of the heavy lifting by using PaaS services. So it wouldn't really make a lot of sense for me to go build a load balance web application environment on virtual machines unless I actually needed root access to the OS. If I don't need that, why not just use app service, just focus on the application. And then finally, from a cost perspective, reserved instances or RIs, this is a way for you to make a commitment and kind of sign a contract, if you will, with Microsoft based on your usage. So imagine that you're going to need a server with X amount of CPU and memory, and you're going to need it in the West US2 region for at least a year, maybe 2 years, or maybe up to 3 years. If you go with a reserved instance from Microsoft and you make this commitment to do 1 or 3 years, they're going to give you a much lower hourly run rate for that infrastructure, and are also going to make it to where they reserve the capacity for you. Because in these regions where we're deploying infrastructure, Microsoft is just basically, if you're doing on demand, you're just spinning up what's available. So certain virtual machine types may not be available depending on the demand for that resource. So if you do a reservation, a reserved instance, you're guaranteed that specific capacity. And you're also, since you're committing to a long-term thing, you're going to pay way less, sometimes up to 72% less, which is insanely awesome. All right, let's talk about Azure networking. Honestly, this is a place where I see most cloud engineers get stuck, because the networking is, it's much different than an on-prem environment. And the way that they do it in the cloud kind of sometimes makes you feel like it's violating some of the rules of networking. An example would be stretching a network across the entire United States, but we'll kind of talk about that. What I want to do, though, is do a little bit of cleanup, though, before we move forward. So I don't want to keep using the compute sandbox or the storage sandbox. So I'm going to go over to my resources here from my user menu, and I'm going to go ahead and delete the storage sandbox. I'm going to delete the compute sandbox. And by the way, if you're using the Range and you just walk away after you've spun up a sandbox, it's okay, because it'll delete on its own after the expiration time elapses. So no worries there if you forget to delete it. But I wanted to clean those up and then come over here, and I'm going to start this networking sandbox. And I got this diagram for you over here, so it's a little bit easier to see. But with the networking, what we're doing here is showcasing one of the core functionalities of Azure networking, which is VNet peering and connecting networks. You notice that there's non-overlapping IP address ranges in each network. And these networks can be peered across either just networks in the same region or across geographies. So West Coast, East Coast, for example. Back in the day, if we wanted to do this, we would have to build a VPN tunnel, and it was really, a lot of work. These days, it's insanely easy to go in there and just say, hey, I want to peer virtual network 1 with virtual network 2. And now I can communicate over that pure connection just like it's a VPN, but without the overhead of the encryption and stuff like that. It's still secure, but it's just a really cool way to make sure that we have cross connectivity to these networks. Okay, so let's go back over the range real quick before I get moving on this. I'm going to go ahead and start this sandbox, and then if time permits, I'm also going to spin up another one that I'm going to talk about, this Azure Firewall Sandbox. This one takes a little bit longer to spin up because there's a ton of infrastructure in there. So I'm going to go ahead and try to spin this one up now while I'm talking about just general networking. Okay, so let's talk a little bit about networking. Again, this can be kind of complex sometimes, but ultimately Azure virtual networks are the equivalent of your on-prem network, same concept, or in virtualization if you're doing like a virtual switch, like in VMware or something, very similar concept to that. We can communicate within those virtual networks with other infrastructure. We know from looking at the diagram, we can peer with other networks, but in a virtual network, or a VNet is what we kind of call it in Azure, those VNets can be carved up into subnets, just like I would do on-prem. So it's very common for you to see people do maybe a front-end and back-end subnet. So internet-facing infrastructure in one subnet, non-internet-facing infrastructure in a back-end type subnet. Some of the services that you deploy in Azure will actually set that up for you, okay? And ultimately, by default, you're gonna have private IPs, which is what we want, right? Just like you would see in the on-prem world. So inside your VNet, you're gonna get private IP addresses for all of your virtual machine infrastructure. The DHCP service is part of the VNet. So if I define my network, like we saw over here, let's go back over the diagram. Kind of jumping around a lot, but if I define my network as a 10 network, 10.0.0.0/16, that's the overarching network address space. I can start carving out subnets. So this is a smaller portion, this /24 subnet. I can create multiple subnets in there, but by default, we're just going to get DHCP in that address space when we spin up VMs. So if I launch a virtual machine into that subnet right there, it's going to get an address of 10.0.0.4 probably, because 4 will be the first usable address from an Azure perspective in that subnet range. Okay, so pretty cool. You don't have to do DHCP. Okay, network security groups are the next thing that's really interesting. This acts like a firewall, and it's something you can connect to a subnet or directly to the NIC on a virtual machine. This just controls the traffic that's flowing across, so within the virtual network, between virtual machines, or even across those peered connections. So you have inbound and outbound rules, just like you would, like if any of you have done like Network Plus or done any Cisco, like CCNA type stuff, just like you would on a Cisco router or firewall, where you're configuring those port rules or those traffic rules, right? So same concept. You can permit or deny certain types of traffic and control the flow of traffic in those networks. Azure's got some insanely good load balancing solutions. So there's the Azure Load Balancer, which has kind of started to shift over time. Microsoft's adding more capabilities to it. But originally, this was just a layer 4 load balancer, meaning you were just thinking about TCP and UDP load balancing, right? Just protocol specific type of load balancing. But now they have things like the application gateway, which can operate at layer 7 of the OSI model. And it can see things that are specific to the application. So we can load balance based on maybe the path of the URL that the user is going to. So like stormwind.com/documents, that could be load balanced to one group of servers, where stormwind.com/downloads might route to a different group of servers. So path-based routing, being able to whitelist certain types of URLs. Web application filtering comes along with that. So Microsoft's got you the ability to basically on a layer 7, like an application load balancer, enable web application filtering. So, things like SQL injections or cross-site scripting attacks can be defended against at the perimeter or at the load balancer instead of having that hit your web server. And then there's other like global load balancing solutions, like Traffic Manager is a really interesting one. Traffic Manager is a DNS load balancer. So if I wanted to load balance East Coast, West Coast web application, I could do that. There's also a newer service called Azure Front Door, which is more like a reverse proxy that works globally like that, has a single endpoint, and also works as a CDN. So that's kind of interesting. VPN Gateway is also a solution just for those VPN tunnels. I'm going to move through this one pretty quick. That's for like hybrid networking scenarios. It'd be possible if you wanted to create a VPN tunnel between two different regions. We've done that before. That might be something to do in the range for the situations where customers are doing hybrid cloud and they want a really fast connection and good throughput to Azure. The express route is a dedicated fiber connection where you can get that installed on-prem or in your on-prem data center, have a direct high-speed connection to the Azure backbone, low latency, higher security, much higher cost, of course. And a lot of times people will pair that with a VPN tunnel. So the express route connection will be the dedicated link from on-prem to Azure, and then the VPN tunnel will be there for failover if there's something wrong with the express route. And these things are really hard to, the VPN and the express route, pretty hard to simulate in a lab environment. VPN can be done. Express route means you got to work with a telecom provider to get a circuit and all that kind of stuff. Now, when networking comes into the conversation, a lot of times what happens here is, not only do we want to peer networks, but we want to communicate from public services privately. What do I mean by that? Well, Azure Storage, like I was talking about earlier, by default, that's got public-facing URLs, and it's designed to work default on the public internet. But a lot of people aren't comfortable with that. A lot of people might be, hey, that opens up an attack surface. We're not willing to do that. So Microsoft now gives us the ability in many of the PaaS services like Azure Storage, Azure SQL, Apps Service, to privately configure those services and to create a link, an endpoint, a service endpoint, and this is called Azure Private Link. You create an endpoint in this private link, and it gives us the ability to communicate from the virtual network to what used to be a public service privately. So from within my VNet, I can initiate a private connection to something like Azure Storage. The traffic never leaves the private environment and never hairpins, it goes out and comes back into the public IP address. None of that. It's all private, right? So that's something that usually is very simple to set up. Like for Azure Storage, you would just go into the configuration and say, hey, I don't want to do public networking. I want to do private, and I want you to create an endpoint in this VNet over here to give me that private communication. So that has been a big service that a lot of enterprises really love, because a lot of them need that isolation for compliance or just for the comfort of doing cloud. Okay, a couple of anti-patterns with networking. We're doing pretty good on time here. Might have to move pretty quick on this last section. But data transfer between regions or peered VNets, again, that's outbound data transfer. So it's not free, right? And like I said earlier, go and do a search for Azure Pricing Calculator. You'll be able to figure out like what those charges would be based on the amount of data. But it can be like one of those surprise costs, right? So data transfer between regions or peered VNets does incur a fee. It's not free. Improper NSG configuration. So remember, NSGs are those firewall rules. If we inappropriately configure that and open the attack surface by being too permissive, that could be an anti-pattern or a pitfall. So always try to do least privilege security. And when we're thinking about that from a networking perspective or NSG perspective, we're thinking about, okay, not only the port and the protocol and all that kind of stuff, but who is the source address coming here to this resource? And we might want to get very specific about that to make sure that we're doing things with the principle of least privilege. Public IPs are really easy to spin up. Those are sometimes get left behind on accident, and those cost money. It's only a couple bucks a month, but you got to watch out for that. You don't have to put public IPs on all your infrastructure. There's ways around that with like using the load balancers. Even for remote administration, we could VPN straight into the VNet if we wanted to, or we could set up some other things like the Bastion host, which I'll discuss here in a bit. All right, so let's talk about security real quick. I know we have about 10 minutes left here. And so let's get into security. I'll just check in to see if everything was up and running. I'll come back and do a couple demos here before the end, but what I wanted to talk about real quick is the firewall sandbox. This one is super advanced. So not only are we just peering a couple of networks, we're actually doing 3. And this pattern is known as the hub and spoke VNet model. So we've got a hub VNet with an Azure firewall, and then we've got 2 spokes, right? So spoke 1 and spoke 2. And so the idea with this is we're really talking about a shared services type of environment. That's what the hub is about. So maybe we've got like some kind of shared infrastructure, like PKI infrastructure, or other kind of core infrastructure for the business in that hub virtual network. But we wanted to isolate it from these other business units, and these other business units might just get their own dedicated virtual network, right? So maybe the entire application environment for a specific app is all built in just its own VNet. And within that VNet, all the resources are there, right? So this hub spoke model is interesting for large enterprises that are doing that kind of model. But in this sandbox, we've got it set up to where everything's peered. So if virtual machine 1 wants to route traffic through the hub, it can do that. It can go basically from VM1 to the firewall, and then the firewall will route the traffic for you to VM2. So definitely a complicated setup, but it's an interesting way to showcase the capabilities of the Azure firewall. The Azure firewall service is another layer 7 type of aware appliance, right? So it does everything that a firewall would normally do, but it also has that application level intelligence. So for both inbound and outbound, like in this diagram, these virtual machines will go to the internet through the firewall, right? So through this guy, if VM2 wants to go to the internet, the traffic goes through this peered connection. He goes out the Azure firewall. And with that connectivity and configuration, I can say VM2 can only go to certain URLs, or anybody going outbound through this firewall can only go to certain URLs. So it's insanely cool, especially when you just want servers to be able to only talk to like Windows Update or something like that. All right, so whoops, I'm on the wrong side. So we talked a little bit about network security groups. Azure Firewall is another firewall type service that I was just talking about a second ago. And then DDoS protection is built in for free. So if you spun up a VNet and put an Azure load balancer in there, there is a basic free tier for distributed denial of service protection. There's also premium versions of that service for DOS protection, DDoS protection. Microsoft's obviously been fending off a lot of craziness with M365, Azure, Xbox Online going back a lot of years. So they're pretty well versed in dealing with those kind of issues, and they take that knowledge and give it to us as well, help us with our environments. When you're thinking about security, you want to think about defense in depth. Think about your application as like an onion with layers that you're peeling, right? From the outside in, we're starting at like things like the physical environment. Microsoft's doing the physical security for us. But as we go down through each layer, like the identity layer, we got to think about multi-factor authentication, strong password policies, that kind of thing. We get to the perimeter. Now we're thinking about DDoS protection, right? Denial of service protection, web application filtering, blocking SQL injections, cross-site scripting, that kind of stuff. At the network layer, network security groups, managing those ports. At the compute layer, not firewall, but more like patching the operating system and making sure that there's endpoint protection on the compute service, like your virtual machine. Then you get application data. So like you're going down all these layers, you want to think about security at every single layer, and Microsoft gives us tools to do that. One reason that I brought this slide in is this is a very common shared responsibility model. We need to understand that, when it comes to security or even just management, we've got certain responsibilities and Microsoft's got certain responsibilities. So, if we're talking about on-prem, everything is our responsibility, right? We're doing everything. But as we go into things like IaaS, well, Microsoft's going to do physical hosts, physical network, physical data center, and then we got to do everything else, right? The OS, all the networking and the configuration, all that kind of stuff. So as you get into more like managed services, you can see here, Microsoft's doing a bunch of stuff from a PaaS perspective. There's some shared responsibilities here, but Microsoft's doing really the heavy lifting, and we're focusing more on, end users, devices, applications, and stuff like that. So that's something to think about with defense in depth as well, right? Because the physical layer is secured by Microsoft. So always think about that. Whoops, I'm on the wrong side again. Okay. Another couple of security service here is Defender for Cloud. This used to be, this used to be Microsoft's Security Center. Now it's called Microsoft Defender for Cloud. Basically what they're doing there is just giving you some threat protection, some guidance for security. Microsoft Intra ID is the identity as a service solution on Microsoft. Gives us SSO, so single sign-on, gives us multi-factor authentication, also conditional access, which is a premium feature, but this is really cool because with conditional access, we can grant or block access to people coming into our environment based on the device that they're on or based on where in the world they actually are. So we could deny anybody that may not be in the US, for example. Now, here's a couple things. When it comes to permissions in the security conversation, Microsoft Intra ID is for authentication, and then RBAC is for authorization. So RBAC is role-based access control. And this is how we essentially say, you are allowed to do this. We know who you are because you're authenticated. You have access to this resource group, or you have access to this subscription and all the resources that are within it. Okay, so what I'm going to do now is, I think I'm going to speed through this last couple ones, talk a little bit about encryption. Encryption is available by default, and anything stored in the Azure platform is encrypted. But I want to kind of move through this and talk about the Azure Bastion, and then I'm going to do a quick demo here. I know we're getting short on time here. So Azure Bastion is a PaaS type service for remote administration. This is a way for us to go through a Microsoft managed remote administration infrastructure, and we deploy this along with the Azure Firewall sandbox. Okay, so this eliminates the need for public IPs on your virtual machines. You don't need to RDP or SSH directly to virtual machines. You can go to the Bastion. It reduces the attack surface for you, supports MFA. It's insanely cool. All right, so let's jump over to the Firewall sandbox. That one is finally up and running. And if we jump over to the Azure portal, let's see here. Notice we got like a ton of infrastructure in here, right? Like if I wanted to remote into virtual machine 1 on this list here, VM1, I would come into VM1. If I come up to connect at the top, we can connect via Bastion. And so the Bastion was deployed in that hub virtual network we were looking at earlier. So I can literally RDP or SSH through the Bastion, through the hub network into one of the spokes. And that's essentially what would be happening here. You can see here on this screen that I'm being prompted for my username and password. That is on this screen here at the bottom. So I'm looking at this stuff. So if you're spinning this stuff up later on your own, I'm just going to copy this password here. So Azure user is the username, and then password. Click on connect. We have a pop-up blocker. We don't want to block the connection. We want to open it. Click on allow. And by the way, that was a Linux virtual machine. And you can see here, kind of hard to read, but I'm getting the terminal here. And so notice it's saying IP address for ETH0 is 172.31.0.4. And this is VM1, right? So if we come back over to the diagram, see how spoke 1 is in that 172 network. So we're on the VM. He's using the first IP address that's usable in that subnet, which was the 0.4. And the other guy over there was in a 192.168 network. So he's probably got a 192.168.0.4 IP address. So just as a test here, I should be able to ping 192.168.0.4. I put a period at the end. That's not right. There we go. So we're getting a response there. So we're literally, connecting through the Bastion, pinging across the peered networks, going from VNet 1 to VNet 2 through the hub. I know it's kind of crazy, right? But that'd be something to check out. Also, if you just go into the networking one, whoops, I wanted to compute. If you go to the networking one, you can come in here and then ping across, like connect into VM1, ping across to VM2 to test that out.